Hello everyone, I am Sir Gypsy Corpus from Campiño National High School, your teacher presenter for Teletaroan. What happens to solids, liquids, or gases when they absorb or release heat? Does heat affect all kinds of materials in the same way? Heat transfer happens around us all the time. Although we do not see how this process actually takes place, its effects are evident. In fact, we rely on these effects every day in many of the activities that we do. Understanding the concepts behind the heat transfer, therefore, helps us to do our activities more efficiently. This time, you will learn more about heat transfer by exploring its effect on materials. You will also learn about the factors that affect the amount of heat that an object can absorb or release, and describe how these are related to the amount of heat transferred. Remember that heat is the transfer of energy between objects or places because of difference in temperature. Heat exists as energy and is not contained in an object. The energy that is actually contained in an object due to the motion of its particles is called thermal energy. The thermal energy of an object is changed if heat is transferred to or from it. Since the amount of heat transferred relates to the amount of change in thermal energy, the term heat is also used to refer to the measure of thermal energy transferred. You learned in the previous discussions about moving objects possessing kinetic energy. All the objects that you see around you that are moving possess kinetic energy. But do you know that even the very small things that you cannot see, like the particles of the objects, are also moving and have kinetic energy? It can be inferred that the speed of the particles of water varies in each container. Since kinetic energy depends on speed, the kinetic energies of the particles also vary. During the course of our discussion, let us try to answer the following. How is temperature related to the speed of the particles? And how is temperature related to the kinetic energy of the particles? If heat is added to an object, the particles of the object gain kinetic energy and they move faster. Since temperature is directly related to kinetic energy, any gain in kinetic energy would cause the temperature to increase. Conversely, if heat is transferred or removed from an object, it loses kinetic energy. Its particles move slower and the body's temperature decreases. You know that temperature is measured by the use of thermometer. You have most probably used this device many times. The thermometer commonly available in our schools are liquid thermometers, which is a column of either mercury or alcohol. When the thermometer is placed in contact with any object of the mercury column, it either rises or drops. Now, why does the liquid inside the tube of the thermometer go up and down? This happens because the mercury inside the tube expands or contracts in response to a change in temperature. When the thermometer bulb is placed in hot water, the liquid inside the tube expands. As it does, it takes more space and so it goes up the tube. When the bulb is placed in cold water, the liquid contracts and so it goes down the tube. In physics, this is called thermal expansion, another effect of heat transfer. But thermal expansion does not apply only on the liquid inside the thermometer. In fact, it applies to almost everything around us, be it a solid, a liquid, or a gas. There are so many applications of thermal expansion around us. Some are beneficial to us. Others can also be a burden. One example of thermal expansion in solid is the sagging of electrical power lines or telephone wires on hot days. This happens because heat causes them to expand. Have you ever wondered why it is difficult to open a jar that was just taken out of the refrigerator? or why motorists are advised not to overinflate their car tires or fill their gasoline tanks to the brim. How will you apply the concepts of thermal expansion to explain all this? Another change that may occur when heat is added to or taken out from an object is phase change. For example, you know that water can change from solid to liquid or from liquid to gas. What happens to the temperature of water while changing from ice to liquid water? What happens when ice melts? How can you describe the temperature of the water while the ice melting? How about the temperature of the water after the ice has melted? Remember that a change in temperature indicates a change in kinetic energy. In this case, there was no change in the kinetic energy of the particles. So what happened to the heat energy that was continuously transferred to the water? The energy absorbed by the water is used by the particles to overcome the attractive forces between them and not to increase the speed of particles. The temperature of the water will only start to increase after the ice has totally melted. What if you continue to heat the water further until it boils? What do you think will happen to the temperature of the water? The temperature remains the same when ice starts to melt and until all the ice has melted. Then the temperature rises again until water boils. The temperature remains constant at boiling temperature when water starts turning to steam and until all the liquid water has become water vapor. This can be illustrated by this graph. In our previous discussions, you found that the high temperature water transferred more heat than water at a lower temperature. This is shown by a greater increase in temperature of the object that absorbed the heat. What other factors determine the amount of heat that a body can transfer? What is the relationship between the mass of a material and the amount of heat it can transfer? Earlier, you learned that materials expand when heated or contract when cooled. This time, you will study another thermal property of materials, their ability to absorb or release heat that results in temperature change. In science, the amount of heat needed by a material to increase its temperature by a degree is called heat capacity. To be more specific, the term specific heat capacity is used, and this refers to the amount of heat required to increase the temperature of 1 unit mass of a given material by 1 Celsius degree. Different materials have different specific heat capacities. Many metals have low specific heat capacities. This makes them easy to heat up and cool down. Water, on the other hand, has a high specific heat capacity, and so it takes a long time to heat and a long time to cool. This makes the water a good coolant for car radiators. Because of its high specific heat capacity, it can absorb a large amount of heat without causing its temperature to rise too high. Thank you for your active participation. I hope that you learned a lot. This has been Sir Gypsy Corpus of Camp Peña National High School. See you again next time. Goodbye.